All right, so alright, I walked around and I feel like just about everybody got number 1 right, so I went ahead and put the answer up there and don't feel like I need to go over that. But then we had a whole bunch of discussion, which is great, about number 2. And what I wanted you to do was to take this equation and solve it for h using b and r and h, not using any numbers. And so what did you guys get? What does h equal? Nice job. Alright, and then same thing, take that equation, don't use any numbers, and tell me what r is.
R equals the square root of b over pi h.
Perfect. Alright, so if you didn't get that right, it's okay. Just correct it. So you're just dividing, and then on the r one, you do have to do the square root. Then once you get those, what I wanted you to do is design this new can. So in case you didn't read it, you are now working for Bubbly, making disgusting flavored water. And you are going to redesign a can that's going to be taller, and then one that's going to be wider. But the same amount of bubbly is going to go in it. So you're not getting any more bubbly, you're just changing what the can looks like. So the volume stays the same. So on the light gray one, if we want a taller can, we need to figure out the radius by using this formula here. So we're going to take this 3.653, put it in for the volume, and then we're going to take the 13 and put it in for the h. Now I did have some people kind of get this wrong because of the way they typed it in the calculator. So I would highly recommend that when you type this in, that you just use the fraction button. Alright, so you start off with the square root, and then put the fraction button, and then put in your numbers. Anytime you need pi, I wouldn't do 3.14, I'd actually do the pi button. And that's what you should get, 2.99. Is that what you got? Yeah, good. All right, then we're going to use the other formula that we are going to make a wider can. This can is super weird. It ends up like being a bowl kind of. So anyway, we need to find the height of the wide can by using that height formula. And you should get that this is 5.74 centimeters. Okay. Does it make sense that when you made one of the dimensions bigger, the other one got smaller? Yeah, so if you need the volume to stay the same, then they have to change. Now, they don't change proportionally. This one made a way bigger change than this one did. And that has to do with the radius being squared. All right, so number 4 says that a colleague argues that doubling the radius of the can and having the height will keep the volume the same. Is this true? Somebody tried it out. Nevaeh tried it out, and she said no, it wasn't true. What's the problem? Why doesn't it just work that way?
It actually doubles the whole
It does, because the radius is being squared. So when you square that radius, that's already being multiplied by 2, it multiplies it by 4. And so that doesn't work that way. So because the radius is being squared, it has a greater impact on the volume. And knowing that can help us answer number 5. So Food Lion sells bubbly water and is offering a sale on its individual cans for the price of an original can of bubbly. You can choose either a can with the same height but twice the radius, or a can with the same radius but twice the height. Which one is going to be the better deal? Which one would have the most volume? A. And the reason is basically the same reason that we wrote for number 4. When you square that radius is being doubled, it has a greater impact. Okay, so on the other side, we're going to fill in a few notes and then do some examples. We're going to do 4 examples. Now, I think about this time last year in Algebra 2, you were doing lesson where you just rearrange formulas. So it's been probably about a year since you've done it. You probably did it other times in Algebra 2 also. But we will do a lot of the things you did in Algebra 2, but probably at a higher level most of the time because it's pre-calculus. So anyway, formulas can be rearranged, I should say. To solve for a given variable. All right, and then it's just we kind of already figured this out with the radius being squared. But scaling dimensions does not always affect volume proportionally. All right, and so a lot of times these volume formulas, I'll give you the formula because it's just a whole lot to remember. And so on this first example, the volume of a sphere is 400 pi inches cubed, or cubed inches. And then we want to know what the radius of that sphere is. So what we're going to do is take this formula for a sphere, the volume of a sphere, and we're going to solve it for r cubed. Just kidding. We're going to solve it for r. What would you guys do first to solve this formula for r? Not yet. We're going to do a cube root, but we're going to wait. What would we do before that? We're going to divide by 4/3 pi. It's going to look messy, but that's okay. And that is going to equal r cubed. And then anytime we want to get rid of a cube, we're going to do the cube root. So r is going to be the cube root of the volume divided by 4/3 pi. Alright, so let's use that to find the radius of the sphere. Now, I think it was Jaden yesterday asked me how you do the cube root in the calculator. Do you guys know?
You can get blue button under the clear button and then the 3.
That's how you cube.
Oh.
We're going to do a cube root. It's okay. Do you remember? You're going to hit math, and then which choice do you think it is? Well, we can do 5.
Or 4.
4 is a little easier for cube root. 5, we can make it any kind of root we want, but 4, we can it's just cube root. All right, and then we're gonna do the little fraction guy. All right, in the place of v, I'm gonna put what my volume is, which is 400 pi. We technically could cancel out those pi's, but it's not hurting anything. And there it is. All right, I'm going to write in the steps where we put in the numbers, just so you can have it on your paper. All right, and we just type that in the calculator, and we got 6.69 inches. All right, any questions on that one? All right, and then number 2, we have the surface area of a cylinder is given by that formula. It's kind of an intense formula, actually. We're going to write an equation for the height of the cylinder in terms of the surface area and the radius. So that's just kind of a fancy way of telling you to take this formula and solve it for h. So what would you guys do first? Not yet. That's what we're going to do second. Before we do division to solve an equation, what do I need to take care of first? That's division still. Subtracting. So when you solve an equation, if there's addition or subtraction, you move it over first. So the first thing I would do, because this is being added to that, I would subtract it. Or some people, I like to think of it like if it's positive on the right side and I want to move it to the left, it becomes negative on the left side. Okay, now we're going to do all the stuff you guys wanted to do. So now I'm still trying to solve this for h. So there are 3 things that are being multiplied by that. So I can divide by them all at the same time. Oh. I didn't know what that was at first. Thank you. All right, so then I have it. H is going to be equal to that crazy looking fraction. All right, and this time we didn't have to do anything with it. We just had to solve it for h. All right, and then number 3 says that the directions on Funfetti cake mix, which is definitely the best cake mix, suggests using either a 10-inch round pan or an 8-inch square pan. Which pan will give you the taller cake? So, which one? Like, how are we going to decide that? It's the same amount of stuff you put in, so it's the amount of mix no matter what pan you use. Would a smaller base make it taller or a bigger base make it taller? Smaller base makes it taller, so we're looking for the smallest base. So all we have to do is find the area of the circle and the area of the square. So that 10-inch, is that a 10-inch diameter or is that a 10-inch radius on a pan? Definitely a diameter. If you can picture a 10-inch that would be huge. Like you could definitely have a cake like that. Well, maybe if it was a wedding cake, but I don't think it. Funfetti would be a pretty fun wedding cake though. All right, so it's a 10-inch radius. How do you find the area of a circle? It's a 10-inch diameter, sorry. How do you find the area of a circle? Pi r squared. So the diameter is 10, the radius is 5. All right, so if we put this in the calculator, just pi times 5 squared, that's going to be 78.54. How do you find the area of a square? The side squared. Or length, you can still do length times width and they're the same. So whatever. We need to multiply 8 times 8 or square 8, whatever. So that's 64. So which is going to be taller? Yeah. Square makes taller cake. And then the last question, sorry, I'm writing kind of small. The last question is kind of a tough ACT question. So the volume of a right circular cylinder A is 22 cubic centimeters. What is the volume in cubic centimeters of a right circular cylinder with twice the radius and half the height? Before today, you might have said the answer was 22, but we know on these cylinders, because that's what the can was. The can was the cylinder, and we did a situation where that person said, "Do twice this and half this, and it should be the same." And we all just said, "No, it wasn't the same." So it is not going to be 22. I can promise you that. So let's figure out which one of these answers is it. So the volume of a cylinder is pi r squared h. And I know this original cylinder had a volume of 22 cubic centimeters. So I have this new cylinder. And it has twice the radius. So in the place of r, I'm going to put 2r. It's still going to be squared, just like the radius was squared, but it's twice as big, so we do 2r squared. And then half the height, so we'll do 1/2 h. So what do you get when you squared 2r? 4r squared, yeah. All right, do you guys see anything I can do to make this a little simpler, to simplify it? Maybe something I can multiply? 4 times 1/2, right? I can multiply 4 times 1/2. What do I get? 2. All right, so the original volume was pi r squared h, and I got 22. My new volume is 2 pi r squared h, so what should I get? 44. It's telling you to take 2 and multiply it by pi r squared h, and that should give you 44. That's a tough one to get right, for sure.